Welcome. This is Sample Size Calculation 101, the 1,000-year-long course, Hell version. Yes, welcome. You made it. Oh, sorry, guys. Sorry, no. This is actually Paradise. Oh, this soundtrack doesn't help much, right? Yeah, this is actually Paradise, and this just started all wrong. So it was supposed to be like Welcome to the Good Place, but then if you actually watched The Good Place, you would get confused, and if you did not, you're also confused now. So yeah, just don't worry. It's fine. You are in Paradise, and still it is statistics. Yeah, because every statistician on Earth made it to Paradise, as did you. And I know you were not a statistician, but you had PPCR. Remember, it was in your CV. We checked, it counted a lot of points. We're very glad you took it. If you ever get a chance to go back in some weird way and just tell people to do PPCR, it's great. But yeah, so why do we calculate sample size once you just got to Paradise? It's a way for you to understand why you're here, why other people you didn't expect to be here actually came. And we will do it so that you will be perfectly clear. When you get through the green door, everything will just feel natural for you once you did the sample size calculation of who has to come to heaven. So that's our question, right? Our research question. You do remember other better questions, and I'll just take you back to your very first extremely important question, the research question from your group project back in PPCR. The question was, does needling electroacupuncture stimulation of acupoints ST36, ST stands for stomach, right? So yeah, the points were not in the stomach, they were in the leg, but this alternative, very important anatomy will come to you as you pass through the green door. It will just automatically download, so don't worry. Anyway, ST36, ST37, SP6, spleen 6, which was not in the spleen either. Yeah, combined with standard treatment based on ERAS guidelines, decrease the time to first evacuation in 40 to 80-year-old non-metastatic colon cancer patients. Sorry, we're having a lot of breaks here. Submitted to laparoscopic colon resection compared to standard therapy based on ERAS alone. So that was the research question, and you knew it was a good one because it stated clearly who was your population. 40 to 80-year-old non-metastatic colon cancer patients submitted to laparoscopic colon resection, right? Also, you knew your intervention, electroacupuncture, and those points, combined with standard therapy based on ERAS. Also, your control, which was the ERAS only, ERAS alone treatment, and your outcome, which was time to first evacuation, and your time, which was not stated in this question, but you knew it was 7 days and you corrected it later, remember? Yeah, so with all that said, you knew you had a good research question. You also did the final maps thing, so yeah. And because your outcome was time to an event, you first considered a survival analysis, which made total sense, except the big and strong thing about survival analysis was that you could account for censoring. So you could lose patients throughout the way and just be fine with it because you would still have some data to account them for, which was not much of a problem in this case because it was only 7 days. You would have patients accountable for during that time. So you also considered mean time, and that's what we're going to be discussing, not only because it's simpler, but also because it depends on sort of the same principles, let's say, same parameters. And because you considered mean time, you actually thought about T t-test. T-test is powerful. T-test will give you a strong answer, and it's widely accepted. Even if you have some degree of disruption from normality. So yeah, T-sample, T-test is actually good. So we're actually talking about independent t-tests, right? Because we have two groups, one group receiving the electroacupuncture, the other not receiving, so two independent groups, and we're talking about independent t-test. You went for the calculations, which seemed very simple, like you would have to calculate the degree of freedom, the variability, the effect size, but just as you will get here in heaven, a complete unlimited access version of Stata. You also had Stata back then. It was a simpler version, and you would have to type things. You could not just tell it what to do. You couldn't, it was simpler than what you will get here. But yes, you had it, and you only had to understand really well all the parameters. Sorry, we had this technical difficulty, the foggy angel. This foggy thing you see here? It's actually an angel. And well, she just thought about leaving, and we had to wait for a return. Yeah, but we're good now. So significance level, remember, it was something very important. It was usually set to 5%, 1 in 20, which was this, I don't know why, earthly thing you had. It was, remember what it was. It was the chance of rejecting the null hypothesis when it actually was true. Got it? If you didn't, it's fine. Before you pass through the green door, a few things will still remain a little hard, but think of it this way. When null hypothesis is true, it means you don't have any effect. The alpha, the level of significance you would accept, would be the amount you would accept of saying that although it did not have an effect, you would accept the fact that someone would say that it did. Still hard, right? So let's say that for the acceptance in heaven, we had a 5% level of significance. It would mean that 5% of the people who actually came to heaven did not deserve it. Made sense, right? So you set it to 5%. The other thing was the beta. Beta would be the opposite, would be like sending the good people to hell. And usually on Earth, you would accept a 10, 20% beta, which is high number, right? It's a huge number. But yeah, you would accept it. And it would also define your power. Power 1 minus beta. So if beta was 20, your power would be 80, for example. And you know that saying, it's very hard to find the black cat in a dark room, especially when there's no cat in it? Yeah, that's your power. It's your chance of finding something if it actually is there. So if the cat was in there, what was your chance of finding the black cat? That's your power. And you would set it to 80 or 90%, which is, yeah, I understand. Now it doesn't make much sense, but it was good back then. And the effect size, you would usually not have to tell it directly to Stata. You would just say the mean of each group, which you would have to base on something. And in your case, you had a previous study that was not the same, but was somewhat similar. So you could base it on that. It was, I'm not sure, 85 minutes versus 120 something. I know it had an effect of 36-hour difference. So that would be your effect size, 36 hours. But you didn't have to tell that Stata. You would just have to tell the mean of each number and the variability, which was told in a standard deviation way. Standard deviation, remember that? So I'll just make it clear to you. The blue, dark blue part is your one standard deviation in the bell curved shape. Remember the bell curve? Yeah. So this was your normal distribution. If you had a normal distribution with a small variation, you had a smaller bell, a narrow bell, let's say. If If you had a big variation, it would increase, and so would increase your sample size required for that if you had a huge variation. But you did not have for that case, it was 30 something to 50 something. So yeah, it was a good number, and you had a good size effect with not much variation, from which you came to a sample size of 78. Not exactly 78, right? It was 70, but then you had to account for dropouts, which based on 4 other studies you knew were of up to 10%. If other studies did not have more than 10% of dropout and you were doing a good protocol, it's likely that 10% is acceptable, which would lead to 77. But because back on Earth and still not here in Paradise, you cannot split people in half, you had to go for 78. It just made more sense because you had 2 groups, so each group would be equal as you had planned. So yeah, that's how you got to your 78, considering the 2 independent samples with a t-test. Now, when we come to Paradise, how does it work? You also need an alpha. You also will need this data to be terms, and none of the data to you will need the fast size. We will set the data to 100%. We will set alpha to 0, and that's also perfectly fine. And yeah, you probably get it. So this is how and why you're here. Welcome. You're very welcome. We're going to have eternity to discuss more about statistics. Now, please just go through your green door and enjoy the rest of the day, your eternal day.